Alright, this is Lab 4 Circuits. The purpose of this lab was to predict the behavior of circuits containing resistors in parallel and series in a simulation. The physics concepts needed to understand this is how to find voltage in a resistor, your node rule, loop rule, and that the net overall voltage is 0. In the end, I found that the RC circuit was about 5.96 seconds. So the first part of the lab was just trying to predict the amps in the circuit. And I predicted using that voltage equation for resistors to be about 0.0204 amps. And when I used the ammeters, it came out to be that. It doesn't round it. It technically rounds because it doesn't have those extra points, but. And then when I put the ammeters backwards, I got the same exact value of current. I think this is because that amps cannot be negative. It doesn't make sense. And then whenever there was a hole where the ammeter was, the voltage difference was 3 volts because the electrons are running here with 3 volts and then they aren't able to get across. So 3 volts would be the right answer. So to test to see what the voltage difference is between each of the resistors, use the voltmeter again to test between each of them to make this graph. And I found that the difference on the 47 ohm resistor was negative 0.96 volts and the difference on the 100 ohm was negative 2.04. When I add these together, you get negative 3, and 3 volts overall minus that negative 3 would equal 0. So that sounds right. And then I went through and calculated the resistance, and of course, since this is a simulation, it came out to be exactly 47 ohms and 100 ohms. But in real life, they would have, the wire and ammeter would have a resistance, but this is a simulation. Alright, now whenever we use a capacitor, it builds up charge. So with the battery in, it's charging up and the light starts out really bright because electrons can move through here, but it slowly builds up and then the light dims until it's off. And the same exact thing happens without a battery. You take out the battery and it starts to discharge until there's no more electrons left. I used a stopwatch online to find the times. 6.6 seconds to charge, 6.1 to discharge, 10 seconds for the 20 ohm to charge, and about 9 seconds for the 20 ohm to discharge. I used these values and put them into a graph, and I found that the RC circuit, after flipping this and making it positive, was 5.98 seconds. So error, there should pretty much be no error unless I made an error in this, because it is a simulation of the real world and everything is predetermined in this simulation. And our assumptions would be that the wire and ammeter have no resistance, but of course in real life they would have some, but it would be very small and almost negligible. On to our questions. So what if you're doing this lab in real life and use an actual ammeter instead of an ideal simulated ammeter? What's the difference about the real ammeter and how would it have affected the circuit if you hooked it up? Well, I kind of already explained this, but the real ammeter would have a resistance. And then that would make our overall calculations different because we would get different resistance for our actual resistors. I also like to add on that real resistors aren't guaranteed to be the exact value that they say they are. They have a leniency about like 10% of whether it's on that real charge that they say it is. What if you're doing this lab in real life and used a real battery to charge a real capacitor with no resistor in the circuit? I said it would charge almost instantly, but everything has resistance, so it would take a little bit of a time.